Okay, class, we are going to go over the vocabulary for chapter 2. So we're going to start off with the word power. Power means an answer that has a base and an exponent, such as this. This is 2 to the power of 4, which means 2 times 2 times 2 times 2. Power is the answer to that. So if I was going to say this, I would say power of length. So it would be 2 to the power of 4, which is right here. So 2 to the power of 4, which means 2 times 2 times 2 times 2. All right, our next number is base. This is pretty easy in an exponent. It is the number that's being multiplied multiple times. So this is 2 to the power of 4, which equals, if you look at this, it equals 2 times 2 times 2 times 2. So the base is the number that's being multiplied here, whereas the exponent is the amount of times it is multiplied. So the exponent is the amount of times that 2 is multiplied. So 2 is multiplied 4 times by itself. So the exponent is counting these numbers here. 2 times 2 times 2 times 2. That was weird. I don't know what happened there. So the exponent is count how many times the 2 is multiplied. 1, 2, 3, 4. That's what the exponent is. It's showing that the 2 is being multiplied 4 times. So they have special names for the exponents. When we look, cubed is any number with an exponent of 3. So if it is 7 to the power of 3, that is called cube. Any number with exponent of 3 is called cube. So if I take this and I go 8 to the power of 3, that's 8 cubed is how I would say that. So I would say it 8 cubed. And that means 8 to the power of 3. Down here, I would say 7 cubed. 7 to the power of 3. We can go down to our next one. Oh, I have pictures. Woo! All right, cool. So cubed usually goes with volume. So when you have volume, which is on your guys's, some of your guys' desks, volume, we always use it in cubed. Many times it's centimeters cubed, sometimes it's inches cubed. And the reason why we do that is because volume, the amount of space, is measured in cubes, little cubes. Length times width times height. We multiply 3 numbers. Length times width times height, that means cubed. So we have one that's squared. Squared is any number to the power of 2 instead of 3. So this would be 7 times 7. So any number multiplied by itself with the power of 2 is called squared. So it's very important to know the difference between cubed multiplied by 3 and squared multiplied by itself twice. So cubed is multiplied by itself 3 times. 7 times 7 times 7, whereas squared is 7 times 7. All right, so if we look down here, the reason why it's called squared is 2 squared. Well, I have 1, 2. See how they're measured in squares? This is called area. Area is always measured in squares here. So when we measure area, you call it, you use squared. All right, so we're going to talk about commutative property now. And there's a lot of commutative property. Commutative property is when you can switch around addition and multiplication problems and still get the same answer. If we look at this answer, 3 plus 5 plus 9 equals 17. Well, I can do the same thing and switch around that 5 and take that 3 and put it where the 5 is, and I will get the same answer. And that is because of commutative property. I can do the same thing with multiplication. So multiplication, I have 3 times 6 equals 18. Well, 6 times 3 equals 18 as well. When you get to bigger numbers, 2 times 4 times 6 equals 48. I can switch these around because of commutative property and still get the same answer. 2 times 6 times 4 equals 48. I can even do this. Woo! 6 times 2 times 4 equals 48. And that's all because of commutative property. All right, so now I'm going to go down to factors. Factors are numbers that can be multiplied together to get another number. So 8, what numbers can be multiplied to get 8? 1 times 8 equals 8. 2 times 4 equals 8. So factors of 8 are 1, 2, 4, and 8. So if I had another number, let's say 12, let me get that down there a little bit. So 12. What numbers can be multiplied to get 12? Well, think about this for a second. First off, 1 times any number. I'm going to actually make this smaller so I can have a little bit more room to work with. All right. So 1 times 12. Okay? No, those are factors. Well, can we multiply 2 by anything to get 12? Think about. Yes, 2 times 6 is 12. So 2 and 6 are both factors. Are there any other numbers we can multiply to get 12? What about 3 times 4? Can we multiply 3 times 4 to get 12? All these numbers equal 12. Therefore, all the numbers that we multiplied to get 12, 1, 2, 3, 4, 6, and 12, are all called factors. So factors of 12 are 1, 2, 3, 4, 6, and 12. Those are all called factors. All right, now I have a couple more and then we'll be done here. A prime number can only be divided by 1 in itself. It's very difficult to remember your prime numbers. In fact, I kind of forgot one. 23 is also a prime number in there. So all these numbers I can only divide by 1 and itself. 2 divided by 1 is 2. 2 divided by 2 is 1. 3, the same thing. 3 divided by 1 is 3. 3 divided by 3 is 1. So they can only be divided by 1 and itself. Basically, the only factors are 1 and the number. So let's look at 5. Can 5 only be divided by 1 and 5? Are there any other numbers we can divide by to get an even or a whole number? No, 5 is a prime number. What about 6 though? Is 6 a prime number? What if we divide 6 divided by 2? What does that equal? That equals 3. So 6 cannot be a prime number. Can 7? Are there any numbers that could be divided by 7 to get? 7 divided by 1 equals 7. 7 divided by 2 isn't a whole number. 7 divided by 3 is not a whole number. 7 divided by 4 is not a whole number. 7 divided by 5 is not a whole number. 7 divided by 6, nope. 7 by 7 is 1, so 7 is a prime number. Funny thing is, and I'm going to put this in bold, is any even number cannot be a prime except 2. Why is that? Any even number cannot be a prime except for 2. Think about that answer. Why is that? Well, it's because all even numbers can be divided by 2. So they have more than one factor. Alright, and last little bit here. Last little bit. Ooh, I need to fix that. Bear with me while I fix that. Prime factorization is splitting up numbers into primes that can be multiplied together to get that number. And so I will give more on prime factorization a little later. All right.